Hello, welcome to our series of teachings. Today we are looking at the scalar product of two vectors. Remember we started with addition and subtraction of vector. So today we continue from where we stopped in our last class. We are going to be looking at the scalar product of two vectors. We say the scalar product of two vectors A and B is written as A dot B and is defined as A dot B is equals to the modulus of A times the modulus of B cos theta, where theta is the angle between the vector A and B. The angle between the vector A and B. Now, this is what we are trying to say. Let's consider these two vectors. If A is equals to A1i plus A2j, and B is equals to B1i plus B2j. So we say the scalar product, or what we call the dot product. The scalar product is given as A dot B will be equals to A1i plus A2j dot B1i plus B2j. And if you expand this times this will give you A1, B1, I times I. Remember there's I here, there's I here. Plus, if we use this to multiply this, you have your A1 I times B2. So we write it like this: A1 B2 I dot J. Then if you multiply with A2, A2 times this will give you plus A2 B1 I times J. Then if we multiply A2J times B2J, you have A2B2 J times J. So, we know that I times I is equals to 1, and I times J is equals to 0, J times J is equals to 1. So, with that, our A dot B finally become A1 B1 plus A2 B2. So this will be the dot product, or what we call the scalar product of the vector. The scalar product of the vector. And now to obtain the angle between the two vectors A and B, the angle between the two vectors A and B can be obtained. The angle between the two vectors is given as cos theta is equals to A dot B over the modulus of A times the modulus of B. So this is given as what? The angle between what? The two vectors. So if we solve this and get the cosine of this, we can actually obtain the angle between the two vectors. Example, find the scalar product of 1, A is equals to 7I plus 3J minus 4K, and B is equals to 4I minus 2J minus K. Solution. We have A is 7I plus 3J minus 4K, and B is equals to 4I minus 2J minus K. So your A dot B is the same thing as 7, take the position of I, bracket 4, plus 3, where are the J, minus, bracket minus 2, you have minus 4, bracket minus 1. So if you solve that, you have 7 times 4 is 28. That's 28. 3 times this is minus 6. Minus 4 times 1 is plus 4. So if you subtract, you have 28 minus 6. That will give you 22. Plus 4 will give you 26. Remember, the I will multiply I, J multiply J, and K multiply K. Don't forget that. Don't forget that. Now 2. We have our A is equals to minus 3I plus 4J minus, it's already there, minus 5K. Then your B is I minus 2J plus 3K. Remember, we are dealing with the position. A dot B will give me minus 3 I to I, bracket 1, plus JS 4, JS minus 2 times minus 2. Then you have KS minus 5, bracket 3. So if you open this, you have minus 3, minus 8, minus 15. Minus 15, and that will be equals to minus 20. Now let's take some examples on projection. I asked to find the projection of the vector A on vector B if 1, A is equals to 2I plus 3J minus 7K, and B is equals to 4I minus 2J plus 3K. Then 2, A is equals to 5I minus 2J plus 3K, and B is equals to 5I minus 4J plus 6K. So now let's quickly look at this. We'll take them one by one. So the first one we have A is equals to 2I plus 3J minus 7K, and B is equals to 4I minus 2J plus 3K. Now the first thing we need to do is to find, we need to quickly find the projection of B. Projection of B. So to find the projection of B, first of all, let's find the unit vector. Let's find the unit vector B. We know that B is equals to 4I. So the unit vector will be equals to, unit vector of B will be equals to B over the modulus of B. We have done this before in our previous class. So this will be equals to B is 4I minus 2J plus 3K. This is 3K over, here you have the modulus of B is the square root of 4 square plus minus 2 square plus 3 square. And this will give me, to simplify this, you are going to have 4I minus 2J plus 3K over here is 16. 16 plus 4, that is 20, plus 9, that will be 29, over the square root of 29. So that will be the what? The projection of B. That will be the projection of B. So this is the projection of what? This is the unit vector B. So what is the projection of B on A? Projection of B on A. We now have the projection of A. Projection of A on B is equals to A dot unit vector B. Unit vector B. So we have, this will give us A is 2I plus 3J minus 7K bracket 4I minus 2J plus 3K. Everything is over the square root of 9. And if you simplify that very well, this is the same thing as 2 bracket 4 plus 3 bracket minus 2 minus 7 bracket 3. Everything is over the square root of 29. It's over the square root of 29. And this will be the same thing as, what we have there is 4 times 2 is 8 minus 6 minus 21. Minus 6 minus 21. And that is going to give me, that will give me minus 19 over root 29. And if you rationalize this, that will give you minus 19 root 29 over 29. Over 29. So this will be our final answer. Now let's look at the basic properties of the dot vector. Basic properties of dot vector. The first one is A dot B is equals to B dot A. We call this a commutative property. That's commutativity. You can see it here. Then you have KA dot B is the same thing as A dot KB. We call it this scalar multiplication. Scalar multiplication. That is, if K is a constant, then K times A, then times B will give you the same thing as A times K, that's bracket K times B. That's called scalar multiplication. Then we have the distributive property. A dot B plus C is the same thing as A times B plus A times C. Then we also have the modulus of A squared is equals to A times A. And if A if the dot product of A and B is equals to 0, then A and B are said to be what? Perpendicular. So we are going to take some few exercises to illustrate these laws. Take some few exercises to illustrate this law. If A plus B and A minus B are perpendicular, show that the modulus of A is equals to the modulus of B. Solution. Solution. Now, recall that we said that if A plus B and A minus B are perpendicular, it means that their dot product, the dot product must be equals to 0. So, I'll say A plus B bracket dot A minus B must be equals to 0. That's the condition for perpendicularity. That's the condition for perpendicularity. And if we multiply this, A times A is A, this A dot A times this is minus AB, B times this is plus AB, and this time this is what? Minus B dot B, and is equals to 0. So this is minus, this is plus, this can cancel this. And you can show the sign of dot vector here, there's no problem. You can show the sign of dot vector there, there's no problem. So you cancel out, so you have A dot A minus B dot B is equals to 0, and this is the same thing as A dot A is equals to B dot B, because of what? Because of minus move to this side to become what? To become positive. So we've already said that A dot A is the same thing as A, the modulus of A squared, and that will be equals to modulus of A squared, and here will be equals to the modulus of B squared. So which means that A must be equals to what? A, the modulus of A must be equals to the modulus of B. The modulus of A must be equals to the modulus of B. If their modulus square is equal, then their modulus must also be what? Equal. The modulus must be also equal. Now let's look at this example. The position vector PQ and arrow in SY plane. In SY plane are QP is equals to 6I plus 5J. OP is equals to 6I plus 5J. OK is equals to 3I plus 5KJ. And OR is equals to 9I plus 3J, respectively, where K is a scalar vector. If, scalar quantity, if the resultant of OP and OR is perpendicular to QR, find the value of K. Find the value of K. So we are going to quickly take the question. We are going to solve this quickly. I'm going to solve this quickly. Now from the question we're given that OP, the vector OP, this is the solution now. The vector OP is equals to 6I plus 5J Where we have our O arrow is equals to your 9i plus 3j. Now, the resultant, OP, vector OP plus O arrow is equals to 6 plus this is 15i, that is 6 plus 9 is 15i, plus 8j. We are told that the resultant is perpendicular. The resultant, so we have our P arrow will be equals to 15i plus what? 8j. But we have, if P arrow is perpendicular, that's the sign of perpendicularity, to OQ, then we can conclude by saying that we have P arrow, the vector P arrow, the dot product of P arrow and OQ must be equals to 0. Because the condition for perpendicularity is that their dot product must be equals to 0. So this implies that 15i plus 8j times your OQ is 3i plus 5 kg plus 5 kg, and this must be equals to 0. This must be equals to 0. So this implies that 15 times this, remember I times I is 0, so you have 15 bracket 3, 15 bracket 3, then 8 times 5k plus 8 times 5k is equals to 0. So we have 15 times 3 is 45 plus 45. Let me take it the other side. We just put it here. We have 45. 15 times 3 give 45 plus 8 times 5 is 40 plus 40k will be equals to 0. So your 40k, take 45 to the other side with minus 45. The k will be minus 45 over 40. So if we divide using 5, this will be minus 9 over 8. So our k is equals to minus 9 over 8. Now, thank you for being part of this class. In our next class, we're going to be just problem solving. We'll solve some questions related to vector. We'll take general questions before we move to vector 3. We'll move to vector 3. At the end of the next class, I'll give you some assignments to solve. Plus, please don't forget to subscribe to our page. Always subscribe to our page. Make sure you share the page. Announce the page. It's very important. Thank you. God bless you.